So for 3b, again, we're solving between 0 and 2 pi, and the question starts off with sine x equal to cos x. So there's a couple of ways you could do this. One, you could just think of your unit circle. Is the x-coordinate ever equal to the y-coordinate? Do you ever have the same values? And if you can see that yes, we do, when does that happen? 45 degrees or pi over 4. Is that the only place in quadrant 1? Where else? Quadrant 3, they'll both be negative. So you could solve this one just like boom, like that. Just say, I know for my unit circle that they're the same at that place. But what we can also do is a strategy that's similar to what we solved in the first question. If we go back to that first question and we look back at the strategy, when we had two functions that were different in an equation, we said, is there a way that we can write the equation with only one function? And in this example, we could, because we could replace the cosecant x with 1 over sine of x. And so now my equation only had sine. So in this question as well, we can say, is there a way that I can use my identities that I can change this so that I only have one trig function? Okay? And again, here you might be tempted by something that won't work, so I'll show you that at the end. I'll show you the right way first. The right way on this one is if I would divide both sides by cos of x. Can you see that on the left I would have sine of x divided by cos of x? And on the right, if I divided that by cos of x, I would get 1. Why is that helpful? Why does that help me write this as only one trig function? Because sine of x over cos of x is tan. So then this equation becomes tan of x equals 1. Is tan ever 1 on our pi plate? Yes. When? Oh, surprise, surprise, pi over 4 family. In which quadrants? Tan is positive in quadrant 1 and quadrant 3. Yes, we got the same answers, which is a good thing. Okay? Now, a mistake that is sometimes made. Okay? We have the big idea. This is not the mistake. We have the big idea that sine squared plus cos squared equals 1. In some of the questions on the review so far, you've had to rearrange this to get one of them by itself. This is still good. You can get sine squared by itself by subtracting cos squared on both sides. You could get cos squared by itself as well. And we can use this for substitution. The mistake, okay, is that sometimes people say, if sine squared equals 1 minus cos squared, does that mean that sine x is equal to 1 minus cos x? No, but you're tempted to do that. I just square rooted everything. Why can't I do that? That's not that cos is negative, but there's a problem in just square rooting everything. Would you agree? Would you agree that 3 squared plus 4 squared equals 5 squared? That's true. That's a true statement. If you square root everything, is 3 plus 4 equal to 5? No. Okay? When you square root, you have to square root the whole side. But you're not allowed just to square root individual things. That's not true. Okay? Why do we think of this and make this a mistake? It's probably because we feel that there's other times that we've done this. For example, if x plus y is equal to 5, can I multiply everything by 2? Is this allowed? Yeah. This is allowed here. Why is it allowed but not allowed in the other situation? Well, really, when we as math teachers, maybe we're, oh yeah, I would definitely blame a math teacher. That's probably a good idea. Yeah, it's probably a math teacher's fault. at this point. Because we do this all the time, us terrible math teachers. Multiply everything by 2. And the reason it works is not because you're multiplying everything by 2, but the step we never show is really you're multiplying this whole side by 2 and this whole side by 2. But when I multiply the left side by 2, I can distribute. So we just skip to this step and say multiply everything by 2. But you're really just multiplying one side by 2, multiplying the other side by 2. With square roots, that doesn't work because the square root of x plus y does not equal the square root of x plus square root of y. That doesn't work. That's not one of the mathematical rules that you've learned along the way. But I'm just pointing it out because sometimes in a question like this, someone might get tempted, oh, I'll replace cos x with 1 minus sine x because I know that cos squared is 1 minus sine squared. But that is not allowed, so I'm just pointing that part out. Whew. Perfect. All right. Example 1, done.